we can do some numericals relating the chapter oscillations. First question, a spring of force constant 1200 Newton per meter is mounted horizontally on a horizontal table. A mass of 3 kg is attached to the free end of the spring and pulled sideways to a distance of 2 cm and released. Find the frequency of oscillation, find the maximum speed of the mass, find the maximum acceleration. Here in the question, what are the values given? A spring of force constant 1200. Force constant is represented by the letter K. So K equals 1200 Newton per meter. It is mounted horizontally on a horizontal table and mass of 3 kg is attached. So M equal to 3 kg. Is attached to the free end of the spring and pulled sideways to a distance of 2 cm. So what is the maximum displacement here or amplitude here is 2 cm. Okay, so 2 into 10 raised to minus 2 meter. So these are the values given: spring constant, mass and the amplitude. First we have to find out the frequency of oscillation. Frequency is given by nu. Nu equals 1 by 2 pi root of k divided by m. This is the formula for frequency. Equals 1 by 2 pi root of k. What is the value of k? 1200 divided by mass is 3 kg. So it is equal to 1 by 2 pi root here 400. Okay, so root 400. So after simplification you will get the answer as 3.2 second raised to minus 1. Okay, so second raised to minus 1 is the unit of frequency, or it can be written as hertz also. So 3.2 hertz. So frequency is 3.2 hertz. Then number 2, find the maximum speed. We know maximum speed is given by V maximum is A omega. In the derivation we had derived the formula for velocity, and from that maximum velocity is given by V max is equal to A omega. Now what is omega? We know omega is called angular frequency and it is given by root of k by m. Okay, nu is 1 by 2 pi root of k by m and omega is root of k divided by m, and after simplification k is 1200 divided by mass is 3 kg. So the value of omega is 20 radians per second. Okay, so the value of omega is root 400, which is 20 radians per second. So directly we can substitute here A. What is the value of A? Amplitude is 2 into 10 raised to minus 2 into 20. Okay, so 40 into 10 raised to minus 2 meter per second. So this is the value of maximum velocity. And maximum acceleration is given by A max is equal to, what is the formula for maximum acceleration? It is omega square A. Acceleration is omega square x. Here x is amplitude, which is given by 2 into 10 raised to minus 2. Okay, so maximum acceleration is omega square A, and omega is 20 square into amplitude is again 2 into 10 raised to minus 2. Okay. So it is 400 into 2 into 10 raised to minus 2, that is equal to 8 meter per second square. So that is the formula for acceleration. Maximum acceleration is omega square amplitude more omega square A, and its value is 88 meter per second square. Okay children. Now next question, the acceleration due to gravity on the surface of the moon is 1.7 meter per second square. What is the time period of the simple pendulum on the surface of the moon if its time period on the surface of the earth is 3.5 seconds? Acceleration due to gravity on the surface of the earth is 9.8 meter per second square. So here acceleration due to gravity on the surface of the moon is given. On the earth is also we know. Time period of the symbol pell on the surface of the moon we have to calculate, and the time period of the symbol pell on the surface of the earth is given. Okay, so we have the formula for time period. What is the formula for time period of oscillation of a symbol pendulum? Time period is 2 pi into root of L divided by G. Okay, that we know. time period of oscillation of a simple pendulum is t equal to 2 pi into root of L by G, where t represents the time period, L represents the length of the pendulum, and G represents acceleration due to gravity. Now on earth we can write the formula as, on earth time period on the surface of the earth is equal to 2 pi into L divided by acceleration due to gravity on the surface of the earth. On moon, how will you write the same formula? Time period on the surface of the moon is 2 pi into root of L divided by acceleration due to gravity on the surface of the moon. Okay, so time period on the surface of the earth is given 3.5 seconds. Acceleration due to gravity on the surface of the earth, we know it is 9.8 meter per second square. Acceleration due to gravity on the surface of the moon is 1.7 meter per second square. We have to find out which one time period on the surface of the moon. Time period on the surface of the moon equal question mark. Okay, so from the two equations, how will you find out time period on the surface of the moon? Just divide the two equations. Okay, this is the first equation, this is the second equation, 2 by 1. Second equation divided by first equation gives Tm divided by Te equals 2 pi get cancelled, isn't it? L and L get cancelled, so it is given by, what is the formula? Root of Ge divided by Gm. All of the values get cancelled, 2 pi get cancelled, L also get cancelled. So time period on the surface of the moon equals Te into root of Ge divided by Gm. We can substitute equal to time period on the surface of the earth is 3.5. 3.5 into root of 9.8 divided by 1.7. Okay, and after simplification you will get the answer as 8.4 seconds. So acceleration due to gravity on the surface of the moon is 1.7 and its time period is 8.4 seconds. On the surface of the earth is 3.5 seconds and on the surface of the moon is 8.4 seconds. Okay. Next question. The maximum velocity and maximum acceleration of a particle executing simple harmonic motion are 0.4 meter per second and 0.5 meter per second square. Find amplitude and period of oscillation. Here maximum velocity is given. So V max equal to, what is the maximum velocity? 0.4 meter per second. And maximum acceleration is given as 0.5 meter per second square. We know the formula for maximum velocity is A omega. Okay, this is the formula for maximum velocity. And similarly, the formula for maximum acceleration is A omega square. And this is given as 0.4 meter per second and A omega square is given as 0.5 meter per second square. We have to find out amplitude and the time period. Okay. Now, if you just divide the two equations, A omega square equal to 0.5 and A omega is 0.4, isn't it? So, if you divide the two equations, A get cancelled and we'll get omega is equal to 0.5 divided by 0.4 and it is 1.25 radians per second. So, you will get the angular frequency omega. From the angular frequency, how will you find out the time period? We know time period T equal to 2 pi by omega. Okay, time period T equals 2 pi by omega. So, directly we can substitute 2 pi divided by omega is 1.25 and the answer is 5.02 seconds. So, that is the time period. Okay, now how will you find out the amplitude? If you know omega, if you substitute any of the equation, A omega is 0.4, and substitute the value of omega as 1.25 radians per second. So, we know A omega is 0.4 meter per second and substituting omega is 1.25 equal to 0.4 and we will get A as 0.4 divided by 1.25 and if you simplify the answer is 0.32 meter. So, using the direct formula we can find out the value of amplitude and time period. Two particles A and B of equal masses are suspended from two massless springs of spring constants K1 and K2 respectively. If the maximum velocities during oscillations are equal, what is the ratio of amplitudes of A and B? Here the spring constants are K1 and K2 and masses are equal masses are there. Okay, we have to find out the ratio of amplitudes of A and B. We know the maximum velocity, the formula for maximum velocity we know it is A omega. Here the maximum velocities are equal for the two masses A and B, maximum velocities are equal. So we can write amplitude of A, angular frequency of A is equal to amplitude of the spring B into angular frequency of the spring B. Okay, velocities are equal, no? Maximum velocities of the spring A and B are equal. So amplitude of A into angular frequency of A is equal to amplitude of B into angular frequency of B. Clear? Now here we know angular frequency is given by, what is the formula for angular frequency? We know omega equal to root of K by L. So omega equal to root of K divided by Ka divided by mass is equal to AB into angular frequency of B is root of spring constant Kb divided by mass m. Mass of both the objects are equal. The two particles A and B of equal masses. So m and m get cancelled. We can write root of Ka is equal to amplitude of B the root of Kb. We have to find out the ratio of amplitudes, no? So amplitude of A divided by amplitude of B equal to root of spring constant of B divided by spring constant of A. So the ratio of the amplitudes of A and B is equal to root of spring constant of B divided by the spring constant of A. Okay. A glass window may be broken by a distant explosion. That's the question. Why? So distant explosion produces sound waves and that produces forced vibration, that is similar to the forced vibration, and whose frequency may be nearly equal to the frequency of the glass window. Okay, so the forced vibration, the frequencies may be nearly equal to the frequency of the glass window and the resonance condition is satisfied. That is, if two frequencies are nearly equal, natural frequency and the applied frequency are nearly equal, resonance condition is satisfied and hence vibration increases and the glass may break. Okay, so that is the reason. Sound waves produces forced vibration whose frequency may be close to the natural frequency of the glass. Now resonance condition satisfies, vibration increases and the glass window may breaks. The bob of a simple pendulum is made of wood. What will be the effect on time period if the wooden bob is replaced by an identical bob of aluminium? We know the time period of simple pendulum is given by 2 pi into root of L divided by G. That means time period depends on length of the pendulum and acceleration due to gravity. If the bob, the wooden bob is replaced by aluminium bob, what happens to the time period? Is there any change in the time period? No, because the time period does not depend on the mass of the bob. Even if it is a wooden bob, aluminium bob, or copper bob, any type of bob, time period does not depend on the nature of the bob or mass of the bob. It depends only on length and the acceleration due to gravity. So there will be no effect because time period does not depend on mass or nature of the bob. A vibrating simple pendulum of time period t is placed in a lift which is accelerating upwards with acceleration a. What will be the effect on the time period? So a simple pendulum is placed inside a lift and the lift is moving upward with an acceleration a. What will be the effect on the time period? We have the time period formula t equals 2 pi into root of L divided by G. When the lift is moving upward, what happens to the net acceleration? So here, if the lift is moving up with an acceleration a, okay, here the lift is moving up with an acceleration a, what are the forces acting on the lift? Weight is acting downward, mg is acting downward and the normal reaction is acting upward. Okay, perpendicular force, normal reaction is acting upward. So here in this case 3 forces are acting. Weight is acting downward, normal reaction is acting upward. In addition to that, acceleration by the external acceleration. Here the lift is moving with an acceleration A, that is given in the question, no? So there is another force due to this acceleration. So 3 forces are acting. Normal reaction in the upward direction, weight is acting in the downward direction, and the force due to the acceleration. Clear? So here we can write the formula as R normal reaction is greater because it is moving upward. So R minus mg is equal to ma. If the lift is moving downward, we can write mg minus R equal to ma. Since the lift is moving upward, we can write R minus mg is equal to ma. R is the normal reaction. Clear? And here this can be written as normal reaction is m into its acceleration. Let the acceleration be g dash. Okay, minus mg is equal to ma, or g dash is equal to, we can write a plus g. So the net acceleration due to gravity is the total original acceleration due to gravity plus a. So a plus g. So that means acceleration due to gravity increases, isn't it? If the lift is moving upward with an acceleration a, the total acceleration due to gravity increases. So since the acceleration due to gravity increases, what happens to the time period? Time period decreases. Since acceleration due to gravity increases, the time period of oscillation decreases. That is the answer. Okay, children?